Yellowstone National Park is renowned for its beauty and for being home to the world's largest supervolcano. But there's another reason why this park is so famous, and that's because of the weird boiling water that's found all over the place. That's right, there are dozens of places around the park where you can see water that's boiling at temperatures hotter than 200 degrees Celsius, which is hot enough to cook a nice piece of steak. This water is not only found in rivers and lakes, but also bubbling up out of the ground in the form of mud pots, and it's even been found deep under miles of ice in the park's frozen lakes. So what's going on here? Why is there boiling water everywhere in Yellowstone? And how is it possible that this water exists despite the extremely cold temperatures? For centuries, people have been coming to Yellowstone to experience these amazing geothermal wonders. But it wasn't until modern science came along that we started to learn more about what's really going on here. The first thing we need to understand is that there are lots of different types of geothermal features at Yellowstone, like geysers, hot springs, and fumaroles, which just means any kind of vent that releases steam or gases from inside the earth. Some of these features are just a few feet across, while others can be many acres in size. They also range in temperature from relatively cool pools to those with temperatures that can exceed 90 degrees Celsius. Of course, there's also the super-famous Old Faithful, which is just one of more than 500 geysers in the park. All of these features are created by the same thing, which is magma. As magma makes its way up through the crust of the earth, it heats up the water that's found in the rocks and soil. When that water reaches a certain temperature, it becomes superheated water vapor, which is less dense than the surrounding rock and soil, so it starts to rise toward the surface. As it rises, it continues to heat up and eventually boils, which is when you start to see things like steam and gas being released. The deeper the water is, the hotter it can get, which is why some of these features have such high temperatures. Now, you might be wondering why the water doesn't just keep boiling until it all evaporates. Well, that's actually a good question. You're probably used to seeing water boil at 100 degrees Celsius, but that's only true when the pressure is normal atmospheric pressure. However, the water at Yellowstone isn't just boiling at 100 degrees Celsius because of the high pressure deep underground. The water actually reaches a much higher temperature before it starts to boil. If you've ever been scuba diving, you may have seen a scuba diving watch that has a special scale on it called a manometer, which is used to measure the pressure of the water at depth. As you dive deeper and deeper, the pressure increases, and if you look at your gauge, you'll see that it goes up and up and up. Every 10 meters of water has the same pressure as 1 atmosphere, so at 20 meters, you're experiencing 2 atmospheres of pressure, and at 30 meters, you're experiencing 3 atmospheres of pressure. The pressure at the bottom of the ocean can reach hundreds of times greater than the Earth's average atmospheric pressure. This extreme pressure keeps the water from boiling at normal temperatures. In fact, at 275 meters underwater, water can reach temperatures of up to 275 degrees Celsius without boiling. This might be starting to sound familiar because the deepest part of Yellowstone Lake is 274 meters deep. Now, scientists don't think that the water in Yellowstone actually gets that hot, because that would mean that the magma chamber would have to be very close to the surface, which it's not. Instead, they think that the water in Yellowstone reaches a maximum temperature of about 250 degrees Celsius, which is still hot enough to cook just about anything. But it's not quite as hot as the water in the deepest parts of the ocean. So why does this water stay liquid? Shouldn't it turn into steam at 250 degrees Celsius? Well, believe it or not, that's a great question, and the answer is no, not necessarily. You see, most people think of steam as being white, but if you've ever been to a power plant, you've probably seen that steam can actually be quite clear. What happens is when water turns into steam, it expands in volume by 1,000 times, and when it does, it forms bubbles. If those bubbles are on the surface of the water, then they'll be filled with air and will look white. But if they're deep underwater, where there's no air, then they'll be filled with water vapor. And since water vapor is invisible, the bubbles won't be either. At Yellowstone, the water is under so much pressure that it can't turn into steam, even when it reaches 250 degrees Celsius. so it just stays in liquid form. The bubbles can only form once the water reaches the surface and the pressure drops. And when they do, you see things like steam and gas escaping from the water. This also explains why the water in Yellowstone doesn't freeze. Even though the park experiences freezing temperatures throughout the year, the water in Yellowstone never freezes over. That's because the water is under such high pressure that it has to be cooled to around -25 degrees Celsius before it freezes. And that's not something that happens naturally in Yellowstone. In fact, if you've ever been to Yellowstone in the winter, you may have seen areas of the park where the surface of the water is covered with ice, but there's still plenty of unfrozen water underneath. That's because the water under the ice is still under high pressure and hasn't reached the point where it can freeze. So there you have it. That's why Yellowstone is full of boiling water and why it doesn't freeze even when temperatures drop below zero. It's all because of the high pressure deep underground that keeps the water from boiling and freezing. Scientists are still learning more about Yellowstone, and there's a lot that we don't know. But one thing is for sure, it's an amazing place to explore and learn more about our planet. Thanks for watching, and I'll see you next time.